Alright, so today we're talking about slope fields. I've gone ahead and drawn this in. If you were doing a traditional FRQ, this would be in your answer booklet. You'll even notice on the question, use the axes provided in the pink exam booklet. For slope fields, we're really just calculating the derivative at the given points, and since we're given an expression of our derivative, 1 plus y over x, and we know that x is not equal to 0, we'll notice there aren't points on the axis. So I'm going to go ahead and I know when y equals -1, our derivative is always going to be 0, so at both of those points I can make the same conclusion. Now, these derivative values are just telling us the direction with which to draw the tiny little lines. Why are you not in focus? Okay, so because y equals -1 here and here, we know it's going to be 0, so we're going to have a flat derivative. Alright, cool, we're still in focus. When x equals 1 and y equals 0, we know we're going to have 1s. So that's going to follow along as if I was connecting the corners. That's why I did this on graph paper. But, and then -1, we're going to have the exact opposite, so same idea, different direction. Alright, when y equals 1, we have 2, and then when x equals 1, that's 2 over 1. So we want to just make sure it's steeper than this. So we want to show that, and then we have the exact opposite over here. It's going to be steep and negative. Alright, when x equals -2, I know it's going to be negative, and then y equals 0, so it's going to be -1/2, so I want it to be flatter than this. And then same here, I have +1/2, so I want this slope to be flatter than the slope before. It's all relative. Alright, now for AP, great. You have 2 points, sine of slope at each point, so this is going to be 2 points total. Which, if you completely forget how to do a slope field, it's usually only going to be a couple points, and you can redeem yourself on other parts. As far as what the exam is going to look like this year, I don't really know. So let's take a look at B. This concept comes up a lot. It's a separation of derivatives. Alright, so let me make sure we have the right amount of space here. Okay, we're finding the particular solution. I'm going to rewrite dy dx down here again. So dy dx equals 1 plus y over x. Now, I want to separate these by variable. So I'm going to go ahead and multiply both sides by dx and divide both sides by 1 plus y. These cancel and these cancel. So I'm left with dy over 1 plus y equals dx over x. Alright, so this right here, I'm going to go point by point for here to explain specifically where these 7 points go. This spot right here is 1 point alone, separating the variables. There's a note here that says if there's no separation of variables, it's 0 out of 6 points. Alright, so once we're here, we want to integrate both sides. So it's going to be 2 points for the antiderivatives because you're going to have 1 for each. So as we're integrating from both sides, I have natural log of 1 plus y. That could be a U substitution problem, or you can do that in your head. And don't forget the absolute values. That's super important in this case. It's always important. And then we have plus some constant. I usually use C. In this situation, they used a K on the key that I'm looking at. Follow your heart. Use something that makes sense as far as just like a general constant, because I'm taking the constant from each side and using that here. All right. This is 1 point alone. So let me get this. This is a point for this one. This is a point for this one. And then you have a point for your constant of integration. That's that plus C that every calculus teacher ever has told you not to forget. All right. Now, I want to solve for that K in some case. And I'll explain why I'm using K because I see now. But I see now. Okay. We're 4 points in. I want to put everything to the E. So I have 1 plus y, and the absolute value is equal to, and remember this is for the entire thing, e to the natural log of x, so e to the natural log of x plus k. This can be split, so we end up with x times e to the k, which becomes c. So I have 1 plus y equals c absolute value of x. Solve for c. C equals 2 because we have f equals -1 plus equal. F of -1 equals +1. So I have 2 here, and then I have -1 here, c equals 2. All right, this is your initial condition, so we're using our initial condition here for that point. Can you still see what I'm writing? Yep, and I'm gonna scooch it up. Cool, cool. All right, so now that I have c and I have this expression of y, I can say y equals 2 absolute value of x minus 1, because I'm rearranging this expression here. And then this is our solve for y point, so that's +1 for solves for y. And then we need to talk about our domain. So what values of x can we plug in? I can't have x equals 0, so I know that x is not equal to 0. I can't have x greater than 0. Since we know our initial condition is f equals -1, f of -1 equals 1, this is telling us that we're looking at the x values less than 0 instead of the x values greater than 0. So we have one side or another. So this is how we've determined our domain. You need to state that in some way for that point for the domain. Cool.